Hello everyone. Today we will discuss about the polarization. What is the role of polarization in day-to-day life and how the previous two phenomena, interference and diffraction, they are able to why they are not able to explain the polarization. So polarization means light is polarized. So in one direction. So the famous the theory started by the famous law known as law of Malus that tells ki the I equal to I naught cos square theta, where this I naught is called maximum intensity and theta is polarized angle. So this is called law of Malus. Law of Malus. Now, what is polarization? Polarization means the light vibrations in particular direction. So, we will learn through this chapter that polarization can only be explained if their vibrations in one direction. I mean, they are transverse wave. I mean, somebody asked what is need of polarization. In the previous two phenomena, interference, diffraction, they tell about the type of light waves, type of waves, and they are incoming, going, incident, and other things. So, what is need of that? Because they don't tell us about the type of light waves, whether light is transverse waves or light is longitudinal waves, or their vibrations are perpendicular, or parallel, or cylindrical, or elliptical, or many more. So that necessity gives the polarization. Now polarization can only be explained that if light is in transverse nature. What is meaning transverse nature? Transverse nature means the propagation of light particle along the perpendicular direction of propagation. I mean, suppose the wave or ray is traveling along x-axis, its molecule vibrate along y-axis. They are always perpendicular. That easily they have proved initially how this happened. They're taking two cardboard and one cardboard in the horizontal place. Then, but we found that light is not transferred through the cardboard. That is known as simply polarization analyzer. So we'll discuss about the polarization and the type of unpolarized light and polarized light. I mean, simply unpolarized light means ordinary light which have the vibrations in all possible directions. That is called unpolarized light. You can say natural light is a polarized light. So what is the polarized light? Polarized light means the vibrations in a particular direction. Okay, we can understand this by diagram wise. Suppose this is the light which is unpolarized light and its vibrations are in all possible directions. Okay, and polarized light means that is showing only in the one direction, either this or one can represent by this arrow. So both are the presence of polarized light. Now about polarization, there is very famous theory started by by Maxwell, because electric and magnetic field are always perpendicular. So why not they are perpendicular, so the vibrations are perpendicular. So later on the theory also famous, but I can tell you starting with polarization, production of light, plane polarized light. The first is production through reflection light, production of plane polarized light through refraction light, through double refraction, through scattering, and many more phenomena are there. I mean, there are certain special crystals. They play important role in the polarization, like borax, like quartz, or many more examples are there. So, how light polarize? Because it incident light, a certain crystal. After that, the reflected light become plane polarized due to property of that crystal. quartz, calcite, nitrate, many more are there. So the famous law in this polarization start with the Bristol law. So what is Bristol law? We'll discuss about the Bristol law. Bristol law tells that mathematically it is nothing but mu equal to tangent of IP angle. This is called my refractive index, and this is called incident polarizing angle. Incident polarizing angle. Angle which polarized angle. Tangent of. So one can define that the tangent of incident polarizing angle equal to refractive index. That is the Bristol law. And about this, there is very interesting result comes out that let us suppose that this is interface medium, and in the downward, that is the, you can say, bottom medium or any other medium which has certain refractive index mu, and this is the upper medium. Suppose a ray incident on this, okay, and you can see we can draw normal here. This is normal point. This angle is called IP angle. IP angle. So what will happen from this? This is my normal point, normal perpendicular, and this is called your incident light. Incident light ray. So we'll see that it may reflect along this side. It may refract along this side. So this is the angle that is IR, or simply you can say the equal angle IP. This angle is R angle. Okay. Now see the point, you can put A, B, C and D. These are points you can say, and this is the line that divides two medium, interface line you can say. So let's apply the Bristol law at, Snell's law at B point. So at B by Snell's law, that tells about that this is air medium, this is denser medium. So that tells about that mu Ag, that is equal to, simply we can write mu sine I upon sine R. This is very common formula, Snell's law. This you can have equation number 1. I become IP, you can say IP here, because IP is this angle, IR this angle. Now, but what about the Bristol law? Bristol's law, that mu equal to tan IP. Equation number 2. Now from 1 and 2, see the interesting result from 1 and 2, you will observe that this mu and mu, they are same. So you can say sine of IP upon sine of R equal to this tan IP. Okay. Further you can change in terms of sine and cos very easily. So this is sine IP upon, that is your cos IP. So you will see that these are same. So you can cancel out from this. So your equation become sine R equal to cos of that IP. Okay, this is angle. So you can say here, you can convert this. That can be written as the sine 90 minus IP. Okay, so you can again remove sine. So what is the result? That angle R equal to 90 minus angle IP. Okay, now one can say that angle R plus angle IP equal to pi by 2. The sum of these two angles is 180 degree. Now see the resulting interesting result from the diagram. Now here what we are saying, this angle IP angle and this angle the sum of this is 180 degree, I mean 190 degree. And so this is the, what is this angle? Because straight line tells about the 180 degree. So 180 minus 90, 180 minus 90 become 90 degree. So this is 90 degree. Okay, this is 90 degree. That tells that your refracted ray and refracted ray both are perpendicular. Okay, I mean refracted ray, that is represented by this BC, and refracted ray, that is represented by BD. They both are perpendicular. Okay, that is very interesting result. Okay, so I know there is a requirement of the transverse wave means perpendicular. So this is the interesting result ki how that although both are the polarized light, we can represent this by this dot line, and this we can represent by arrow. Okay, but these two are, this is, you can say they are perpendicular because basic formula. So now what is next ki how the plane polarized light obtained? You know, there is a certain crystal I told you, calcite or quartz, borax. These are certain special crystals that is the available in the free in the nature. So nowadays number of devices are available. There are quarter wave plate, half wave plate, or many more devices are there. Polarizing sheets are there. They are widely used in our day-to-day life. Although sometimes we ignore that type of problem surrounding us, directly we are using that kind of the polarized light. See the headlights of the any vehicle like car, motorcycle, how the light is polarized, beam is polarized a certain direction. Okay, beam high, low. So do you think polarites play important role? Polarites and polarization light is polarized in one direction, so that there are chances the vehicle coming from opposite direction will not be so much disturbed. So polarizations are play important role in day to day life, and nowadays lot of applications are available. Polarization widely used for research, widely used for industry. There are many examples are there. Thank you.